That's so funny.
Oh, I thought it would be hard for you to move. It's hard for me. Okay, so here's the plan. We put my patented piece of plywood down there, right? So we got a nice ramp. And this is on wheels, right? Okay. So all we got to do is lift it up from there and it'll go right down the ramp. But we don't want it to get broken, right? So what we're going to do, you're going to stand down at the bottom.
Okay.
And you catch it.
There's a corner right there.
Now you can't go down there. Are you nuts?
I can't?
No, you'll be killed when this thing slides down there. Get out of the way.
Can I go down there?
Nah. Okay, go. Okay, so plan is let's get the welder down the stairs and we get the ramp in place and it's on wheels, but we want it to roll down very slowly in a controlled fashion. So we find something around with a lot of mass that we can attach a chain to, which would be the Oliver. We'll chain it to him, I guess. Here's the plan. You're gonna do this.
Do what?
You're gonna get this welder down there.
How?
Well, we get a hook onto it, and this handle right here is very strong. Okay, so we should be able to hook onto this handle. So we want the handle facing that way. So spin this around like this. Okay. And then what we're gonna do is right up close to there. All right. We're gonna use the chain fall because the chain fall you can control how fast it lowers it real easily.
Now you move. Oh, I thought it's because you realized you were blocking my shot. I was just about to congratulate you. Having the presence of mind to make sure you had a good shot there. I was about to say, you get a good future as a YouTuber.
Yeah, but now everybody's gonna see my butt.
What?
What?
All right. Okay. That was close.
It bent the handle.
Oh yeah. Well, a little bit. The important thing is it didn't break the front panel. Yeah, keep going. It'll go. Boy, the center of gravity was not where I thought it would be. Stop. You're going too fast again. What did I tell you about that?
I'm doing it.
Yeah, I know, but don't pull so fast. Because it's hanging up on the wood. You want to go down slow and easy. You know why it's doing that, Peter? Because you're not watching. You're not watching it uncoil. That's why you do this. It's way over there. There you go. Mark will help you. Almost there.
Huh?
Almost there. Easy, because you're almost at the bottom. One more. I need some slack so I can take the chain off again. That should do it. Alright, well, I'm not going to slide down there and get hurt. No, I don't want you to. Even if you don't get hurt, you might slide out of control and slam into the front of the welder. Hey, Peter.
What?
No, don't wash your hands just yet. Go down to the basement and unhook that chain. Okay, now, yeah, see if you can just wheel it. Careful, it's going to fall off that thing. Don't get your toes in here. Ah, there you
Why
go.
would you do that?
Perfect. No, leave it. Your hands, then your hands will get like ours. That's good right there, Peter. Don't worry about that. Ooh, I'm lucky I didn't damage this thing a lot worse. I don't remember if that dent was there or not. Probably not. I bet you I just did that. But the handle protected these controls from getting smashed, which is what would have been really bad. But boy, that handle really took a beating. I don't know whether or not, I wonder if I can bend that back. Well, a few whacks with the dead blow mallet and that thing is just about as straight as it's ever been. So you can't even tell that I bent it. So I'm glad that went back the way it did, because that was kind of really a boneheaded move I did there. Yeah, it's a good sized gouge there. I'm not even sure how that happened. I don't think that was there when I bought it though. Alright, let's see what we've got here. This is exactly the way it was when I got it. So I can see that this right here is a retaining spring-loaded nut adjustment here to hold this cover down, which also supports this, which is the guide wheel. Now I see there's two grooves here, and I'm venturing to guess that one of these grooves is for one size wire, yeah, 0.035, and then if you flip it over it's 0.045. So by flipping the wheels over you have two different wire sizes you can use on this machine. And I think you can use other sizes of wire on this machine, provided you buy the right size wheels and guides and everything. So this is 0.035 facing in. Well, that's interesting. This is 0.035 facing out. These wheels are on, I think one of these wheels is on backwards. I wonder why the heck that would be. So it's clear that this upper wheel just freewheels and is driven off of this gear. So this is the driven wheel. This little device right here is a guide. And then I think the gun will have the other guide on it. So I think when the gun is inserted right into here and then must get clamped by this clamp right here. So I don't feel this really doing anything. But I'm sure this is probably supposed to be up like that. Clearly these are your voltage connections right here. This one's black. So this must be negative, and this one's red, so it must be positive. And it looks like they've got the positive grounded to the case here. And so then there must be maybe when you plug the cable in, the MIG gun in that cable assembly must have a connection that goes here. Like that. Over here, this stuff was just rolling around loose inside here. And then up here is where the roller goes, where the roll of wire goes. This was just sitting on here like this, loose. So I can see that there's some kind of spacers here. I don't know if there's anything missing from here. I'm going to have to look at the parts list to see sure whether or not there's anything missing out of this assembly. I mean, why would somebody take this all apart? That's a good question, because it looks to me like this nut goes on here. There's another washer. point, and then there's this. Well, I don't know if this is even in the right order of assembly here, but I'm just gonna throw this stuff on so I don't lose it for now. And there's this thing. This is like a quick disconnect ring. I guess you just slide your spool of wire on there, and then you squeeze this and stick these on like this, and that kind of locks on there. Again, I'm not going to worry about that now because I don't know if this is you know, I have no idea what we're looking at here for potential problems. So what I'm thinking of doing is I'm thinking I'm going to take the covers off and take a peek inside and see if I can't see anything either obviously missing or obviously damaged, or burnt components, that kind of thing, loose wires. I'll look for all of that before I even think about putting any power to this thing. What's great for a job like this is a little adapter for 1/4-inch drive sockets. A couple of 1/4-inch ones here though. Not much to see down there, guys. Well, I'll just give you a quick look over here in case you've never seen the inside of one of these. I've never. You got a big transformer here. Thing's massive. You see, that's where a lot of the weight is. And then, well, these are the cables coming right to the output terminals here. And one of them appears to come right from this, what I thought might have been a transformer, but now that I look at it more closely, I think this might be just a coil, an inductor, a wire wound inductor. Or a choke, as they're often referred to. I'm just basing that on the fact that you got one big thick cable coming in and one coming out, and I don't see any other wires going to that. Whereas this over here definitely looks more like a transformer. You got quite a few taps coming in and out of it. Can't really see anything else here. There's something with a massive heatsink behind this choke up over there, and then there's a cooling fan here. But it looks like if there's any control system type stuff or PC board or anything like that, it's going to be on the other side. Alright, got these screws out. There we go. Oh yeah. What we got here. Here's the other side of that thing that I can see that's heat sinks all over this sucker. So I'm guessing these are the rectifiers. And then looks like that's coming out of the rectifiers. You get these two heavy cables right here coming up to this bank right here, which these are all capacitors. So we must be taking the AC out of the transformer, changing it into DC here. At this point it's going to be a pulsating DC, and we're smoothing it out for a nice smooth DC source with these capacitors. Here's the brains of the unit right here. This is the main PC board. Then, right here, this plate, on the other side of this plate, there's another PC board. But this is this whole module that's been installed here for the spool guns. Alright, something looks... well, that's interesting. This is a screw with a nut right here that's being used to tie together a whole bunch of connections right here, and then it goes through this nylon tie down right here. And this just looks to me like it's something that should be screwed to something. I don't know. Interesting. I could see a solenoid valve right back here. Of course, that's where your shielding gas comes in. So that valve right there opens and allows the flow of shielding gas to come into here. This device back here. So tucked in right back here is a motor, and this must be the gearbox to drive the feed. Yeah, it's funny. It looks almost like a kind of motor you would see like in a windshield wipers or something like that. I've got a relay right here that's just hanging that looks like Yeah, this is what's left of a rivet right here that used to hold this on. That's an easy enough fix to remount that, but that unfortunately would not account for a failure of the system. And the only other thing I'm noticing right off the bat is that there is a pilot, some sort of a lamp right here that looks like it's supposed to go, oh here, it's supposed to go right here. And that is okay, that's on the front panel here. That is a indicator to indicate that the power is on. So this just slips back into here. Well, maybe not. It looks like maybe that's broken. But that's just a simple pilot lamp. Least of my worries. If you're not familiar with electronics and electricity, I would not advise you to even take the covers off of a unit like this. There's some dangerous, potentially dangerous voltages present inside this. This bank of capacitors right here could very easily store a charge. Now, the good news is that the output of this unit is actually relatively low voltage. I think it's like something like 28 volts DC. Matter of fact, these capacitors actually have a rating on them. They're actually 45 volt DC capacitors. So it's telling you right there what they are. They're 15,000 microfarad. So they've got a high capacitance, but they're low voltage, 45 volt DC, which would be the maximum working voltage. And they would never put a 40, if this ran at 45, they wouldn't put the caps in there at 45. So that makes sense. Probably runs at 28. I think a cap's in there that can take up to 45. So even if there was a charge stored in these capacitors, it's probably only about a 28 volt charge. But either way, it's not a bad idea to exercise precaution. Now this unit may have not been operated in quite a while, so I'm not measuring any voltage on that bank of capacitors right now. But that still doesn't necessarily mean that all's safe, so to speak. There's actually a metal plate down the middle. There's 3 metal plates here in parallel. And what that does is that allows them to bank these capacitors. So one side of this capacitor is directly tied to one side of this capacitor. I've changed my meter to the resistance scale, and just for giggles I'm going to look at from here to here and see what we got. And we've got very low resistance, 5 ohms. And on this side from here to here we've got even lower, no, about the same thing, about 5 ohms resistance. That seems awfully low. If this rectifier, or part of this rectifier, or one of these capacitors was shorted, there must be something that limits the amount of current that can be drawn before it triggers some sort of a safety device, a fuse or something. Well guys, it's a day later, and as usual, give me a day and a little time to do a little bit of research, and I come back with a lot more information. And so I thought at this point I would mention some of the stuff that I had said earlier that I was completely wrong about. And I feel kind of silly about it now, but getting to these hookups over here, this is the positive electrode or lead, and it's actually a plus right here, so I was right about that. But I actually thought that this was like grounded to the to this assembly here, but this is actually floating. It's not grounded at all. There's actually a space underneath here. So the positive electrode is hooked up to the gun. So when the gun gets seated in here and clamped in position, it's making an electrical connection to the positive. This negative electrode is where a cable comes through this hole right here, and it's your ground clamp. I totally forgot about the ground clamp. Duh. So that's what this is for, normally. And then it says right here, actually, gun polarity changeover connection, reverse lead connection, negative for electrode negative for flux cord wire. For flux cord wire, the drive assembly becomes negative. So this is the drive assembly. You would take this wire off of here and move it over to this position, and then your ground clamp would hook to here, and that's for flux core wire, according to this, which I didn't realize that, but apparently that's why you would want to switch them around. I learned that these little wheels that are on here, that the fact that these little wheels that are on here actually have these grooves are smooth, means that these were being used for regular wire with gas shielding. When you use flux core, apparently these little grooves right here have little like serrated edges, or a little like knurling in them to help grip the flux core wire. The reason why is because this assembly right here that I was talking about, the reason why this has a spring and it's adjustable is this is how you adjust the tension of how hard it's gripping the wire. Not enough tension gripping the wire and it won't be able to pull the wire. The drive won't pull the wire at a steady rate off the spool. Well, on flux core wire, because it's a hollow wire, the core can get crushed if you have excessive tension on here. So you want to be able to run less tension, so they give you the little knurls on there to help grip that wire because you're going to have less tension. Alright? This assembly right here that I was looking at, there's obviously something very wrong missing over here, because I now know that the purpose of this nut and the washers and all of the stuff inside here is that this is supposed to be, this adjustment of this nut is supposed to change the tension on this spool. If you have a new spool of wire and you release it, it will just go crazy and unwind itself. So what you have to do is you want some back tension on this as you're pulling the spool, and you take the wire off and you feed it through. And if you release the tension, this thing will actually just unwind and cause a complete mess. And from what I understand, it's virtually impossible to wind it back on there. So you end up ruining your roll of wire. My suspicion is because this was completely apart, that they stole something out of here to fix another machine. And that this being screwed up now has absolutely nothing to do with what was originally wrong with this machine, that they took it out of service, unfortunately. So that's that. This big honkin' connection here, this is what's referred to as a sleeve and pin plug. And apparently this is actually a lot more common than I thought in industrial settings. This is a watertight connection. When this is inserted into the receptacle and this is screwed on, there's a rubber gasket here. And apparently this is not that uncommon in industrial applications. I think somebody had mentioned that they thought, somebody had mentioned to me that they thought, because it had a round plug on it, that this was being run off of a generator. But my brother-in-law, who's pretty knowledgeable about this kind of stuff, he works for one of the railroads, and he said, no, he said that's actually a pretty common connection in an industrial application, this type of plug. I was hoping that this was actually pretty valuable, but these are, like, I think they go for like $8 used on eBay or something like that. But if you want to buy them new, they're very expensive. And the funny thing is, I was looking at this one, and this isn't even round, and I'm thinking it's supposed to be. So I don't know whether or not just like this had been squashed by something or what the heck happened there. But if I want to buy, I can't find a used one of these receptacles. If I want to buy a new one of these receptacles, it's crazy money. So I'm going to end up just taking this off and abandoning the sleeve and pin setup and go with something more conventional.